Okay, this is a limit problem where they give you the limit sine of 2x over 2x as x approaches 0 is equal to 1. And they give you this really, really messy limit to figure out. Okay, if you did put 0 in for x, okay, I promise you would get 0 over 0. Okay, you're going to get 0 over 0 if you put 0 in for x. So just straight out substitution isn't going to really help us. Okay, but this isn't as bad as I made it out to be earlier today, because all you really need to do is play around with the definitions of these trig functions and do some rearranging so that you can end up with sine of 2x over 2x. Because if you have that as part of your problem, that particular part of the problem will just turn into 1. Okay? Bear with me here. Okay, what I'm going to do, try not to be too messy and explain this. I'm going to take that top of cosine of 5x, just kind of leave it alone. It doesn't say anything about 5x anywhere. You're just talking about sine of 2x over 2x. So let's kind of leave that alone. Okay, I'm going to rewrite the bottom. But instead of writing this as cotangent of 2x, I'm going to think of cotangent as cosine over sine. So I'm going to rewrite that part as cosine of 2x over sine of 2x. Okay, so on the bottom, I have 8x times cosine of 2x over sine of 5x. I'm sorry, 2x. Cosine of 2x over sine of 2x. Okay, now I know this doesn't look much better, but if we keep playing with it, I think we can make it work. Okay, this looks really, really messy. Okay, let's just kind of play around with the bottom. Let's try to play around with the bottom. Let's turn this into one fraction. Let's turn that bottom into one fraction. Let's turn the bottom into 8x cosine of 2x all over sine of 2x. Okay, and let's keep the bottom as is for now. And I'll be honest, Kip, sometimes with these you just kind of play around with simplifying, and it will just come out that you'll get the sine of 2x over 2x. Okay, so we just turn that into one big fraction on the bottom. Okay, then the next thing I would do, okay, we have something on top, cosine of 5x, and it's divided by this fraction on the bottom. Okay, that's a really messy fraction. It's called a complex fraction because it's a fraction in a fraction. Okay, but to clean up this really messy fraction, I can think of it as the top, cosine of 5x, divided by this fraction, 8x cosine 2x over sine of 2x. But when I think division, I could think of it as multiplying by the reciprocal. Okay, so I could write down cosine of 5x, and then I could multiply it by this big messy fraction flipped over. Okay, hoping this is making sense. I'm going to write down cosine of 5x as the top, and then instead of writing a division sign in the fraction on the bottom, I'm going to write a multiplication symbol, and then I'm going to flip that fraction over. So I'll have sine of 2x over 8x cosine 2x. And boy, isn't this messy. This is really, really messy, but we cleaned up the complex fraction anyway. Okay, think about what we want here. Okay, we're trying to get the limit as x approaches 0, which I didn't write that down at the beginning, but we're trying to get a sine of 2x over 2x. And we're going to kind of just group that together. Look what we got. We got sine of 2x on top. And we don't have a 2x on the bottom, but we could take that 8x and break it apart. We could break that into, we could take that 8x and break it into 4 times 2x if we wanted to. And then look what we have. We have sine of 2x on top, and we have 2x on the bottom. Okay, so it's just now a matter of separating all this messy stuff up, separating it and getting the sine of 2x and 2x together. Okay, I wish I could be talking to you right now so I would know if this is making sense. Okay, but what I'm going to do, I'm going to take the sine of 2x over 2x, and I'm going to write it together. So I'm going to put it as one fraction. Okay, and then I'm going to write down everything else that I have left. Okay, I have, what do I have left here? I have cosine of 5x left. Okay, and I believe that's all I have on the top. That's all I have on the top because that sine of 2x I already wrote down. Now on the bottom, okay, let's see. I still have a 4. Okay, that 8x is, kind of ignore that now because 8x is really the 2x, which I already wrote, and then the 4. And on the bottom, I still have that cosine of 2x. Okay, I just took that sine of 2x over 2x and kind of separated it out. Okay, so now if I find the limit of this whole thing, I know this limit is really 1. And I'm out of room, so I'm going to put 1 here, times, and then I can use direct substitution for this part. Okay, I can use direct substitution for this part, because this part's 1. Okay, if I put 0 in for x, okay, cosine of 5 times 0 would be cosine of 0. On the bottom, I have 4 cosine of 2 times 0, so I'll go ahead and put 0 there. Okay, now the cosine of 0 is 1, so I can rewrite this as 1 times, okay, cosine of 0 is 1. On the bottom here, I have 4 times cosine of 0. Okay, and if cosine of 0 is 1, that's really 4 times 1, which is 4. Okay, so my answer is 1 times 1/4. Okay, and 1 times 1/4 is 1/4. Okay, so the big idea is I kind of took that cotangent of 2x and kind of played with it, made it cosine of 2x over sine 2x. Okay, kind of played around with this really messy complex fraction. Okay, like multiplied by the reciprocal to kind of clean it up. Okay, I tried to group together my sine of 2x over 2x together because I knew that limit was 1 altogether. That whole thing is 1. Okay, and then I used direct substitution for everything that was left. Okay, Kip, I hope this is helping. Email me if it's not. Okay, I can answer some questions through email if we don't do it through Varsity Tutor, because I want to help you with this. I want you to get this. Okay, keep me posted, okay?